Welcome students, we are starting our study on methods of differentiation. In this case we are given f of x is equal to ln squared x and we are expected to use the first principle to find f dash of x. Now by definition the first principle is written as follows. So using the first principle we are actually finding out the derivative of the function. So in this case it's going to be f dash of x is given by limit h tending to 0 of f of x positive h negative f of x divided by h. Now h is a small increment, so the understanding here is x is moving towards x positive h where h is a small change or small increment. So we are expected to find this. Now foremost we are given f of x is equal to ln squared x. Now this is nothing but ln x raised to the power of 2. Now if we are to take the differentiation, we should get f dash of x is equal to 2 times ln of x times differentiation of ln x is going to be 1 over x, which is equal to 2 times ln x over x. So this is what is required. Now first we need to find f of x positive h. So f of x positive h is equal to, now we will have to substitute in place of x positive h. So this is going to be ln squared of x positive h. Now we already have got f of x to be as ln squared of x. So hence limit h tending to 0 of f of x positive h negative f of x divided by h can be rewritten as limit h tending to 0. In place of f of x positive h I am going to substitute ln squared of x positive h. In place of f of x is going to be ln squared of x divided by h. Now I would like to draw your attention to a basic algebraic formula, which is a squared negative b squared is a negative b times a positive b. So using this formula I'm going to rewrite this as ln of x positive h negative ln of x divided by h times ln of x positive h positive ln of x. So this is how I have got, or in other words this is what I've got, and I have used this formula. So now the question comes, how are we going to alter the case? How are we going to change this so that we are able to get the solution? Now we are going to be using this very important logarithmic formula, ln of a negative ln b is equal to ln of a over b, right? So I would be using this over here, so that would give me limit h tending to 0 ln of x positive h divided by x, and of course I've got this h here. Now that is multiplied with ln of x positive h positive ln of x. So this is what I've got. Now from algebra a positive b over c can be written as a over c positive b over c. So I would like to write this as ln of x over x, that's 1, positive h over x divided by h times ln of x positive h positive ln of x. Now there is a formula, limit x tending to 0 of ln of 1 positive x divided by x is equal to 1. So I could achieve this if I am able to have this component over here. So for that I'm going to divide this by x and multiply this by x, and then I'm going to rewrite it using this formula: limit x tending to 0 of f of x times g of x is equal to limit x tending to 0 of f of x times limit x tending to 0 of g of x. Limit of the product is product of the limits. So that's for your understanding. So this is going to be rewritten as the limit h tending to 0 ln of 1 positive h over x divided by h over x. This is one part, and the other part is going to be limit ln of x positive h positive ln of x divided by x. So this quantity is present. Once this quantity is present, I can use limit x tending to 0 of ln of 1 positive x divided by x, which is equal to 1. So this is going to be equal to 1. So of course this is limit h tending to 0. So applying limits, this becomes equal to 1. And if I were to apply the limits, okay, so let me rewrite that. This is equal to limit h tending to 0 of ln of x positive h positive ln of x divided by x. Now I apply the limits. When I apply the limits, this is going to be 0, h is going to be 0, and you get ln x positive ln x divided by x, which is 2 times ln x over x, which is what is this? This is nothing but my f dash of x. So we have achieved the requirement to show that f dash of x is equal to 2 times ln of x over x. And how did we do this? We did this using the first principle. So we will move on to the next question, students. Students, we are expected to find the value of dy over dx. Now we have got this particular equation. The foremost approach that we will have to do is to first simplify, and then we would differentiate. So this is how, in case of huge terms like this are given, this is the approach we should follow. So what I'm going to do is I'm going to rewrite this as y is equal to 1 positive x raised to the power of 1 over 4 times 1 negative x raised to the power of 1 over 4 times 1 positive x raised to the power of 1 over 2. Now we know a formula: a negative b times a positive b is equal to a squared negative b squared. So using that, we would club these two together. In fact, I have written like this, having this formula in mind. So this is going to give me 1 squared negative x raised to the power of 1 over 4 raised to the power of 2 times 1 positive x raised to the power of 1 over 2. Now this is going to give me 1 negative. Now by law of indices, a raised to the power of m raised to the power of 1 over n is a raised to the power of m over n. So if that were to occur, this is going to give me x raised to the power of 1 over 2. And that has to be multiplied with 1 positive x raised to the power of 1 over 2. Using the same formula, this is going to be rewritten as 1 squared negative x raised to the power of 1 over 2 raised to the power of 2. Using the same law of indices, this is going to be 1 negative x. What is there on the left hand side? Y. So you can clearly see the problem which was given in this complicated fashion is now reduced to 1 negative x. So differentiating with respect to x, we get, so what do we get? This is going to be dy over dx. Differential of 1 is 0. Differentiation of x is going to be 1. There is a negative sign, so the outcome is negative 1. So this is a good place for us to draw the red box. So we'll move on to the next question. Students, were given y is equal to x raised to the power of 4 positive x squared positive 1 divided by x squared positive x positive 1, and that dy over dx is a times x positive b. We are expected to find a and b. So foremost, what I'm going to do is I'm going to consider x raised to the power of 4 positive x squared positive 1, and I'm going to rewrite this as x raised to the power of 4 positive 2 times x squared positive 1 negative x squared. So 2x squared added with x squared will give me back this x squared. So now what I wish to do is I would like to rewrite this. So this is going to be x squared positive 1 raised to the power of 2 followed by this negative x squared, because when I expand this using this a positive b raised to the power of 2 formula, I'm going to get this back again. Now this is of the form a squared negative b squared, which can be rewritten as a negative b times a positive b. So using this, I can rewrite this as x squared positive 1 negative, in fact I can, let me have this in this fashion, and that has to be followed by x squared positive 1 positive x. So probably just to identify that this term is present, I have used parenthesis. You don't have to use parenthesis, but just to isolate the terms for easy identification. In fact, you can rewrite this as x squared positive 1 negative x, and then x squared positive 1 positive x. And what is this? This is x to the power of 4 positive x squared positive 1. So I can replace this with this. So this is equal to x squared positive 1 negative x times x squared positive 1 positive x divided by x squared positive x positive 1. Of course, you could have rearranged it, but it doesn't matter. Now x squared positive x positive 1, x squared positive x positive 1, these both can be cancelled. So that would mean you would now have y to be equal to x squared positive 1 negative x. This is what you've got. Now differentiating with respect to x, we get, so what do you get? This is dy over dx is equal to differential of x is 2x, differential of 1 is 0, differentiation of x is 1, there is a negative sign, so we will retain it. So this is going to be 2x negative 1, and this is dy over dx. But what we are given, given that dy over dx is ax positive b. Ax positive b. If I were to take this as 2, if I were to take this as 1, equating 1 with 2, we get, so what do you get? In place of a, you got 2, and in place of b, this is actually, you can rewrite this as 2x positive of negative 1. So that would mean b value is negative 1. So this is a good place for us to box the solution. So we will move on to the next question, students. Students, we are given this question: y is equal to secant x positive tan x negative 1 over negative secant x positive tan x positive 1. We are expected to find dy over dx at x is equal to pi over 4. Now to solve this question, I'm going to take secant x to be equal to capital S, and I'm going to take tan x is equal to capital T and rewrite 1. So therefore 1 can be rewritten as y is equal to secant x is capital S positive capital T negative 1 divided by, this is negative s positive t, right? So let me write it as positive t negative s positive 1. Now we know that secant squared x negative tan squared x is equal to 1. We know that this is famous trigonometry identity. So this would mean s squared negative t squared is equal to 1. So if I were to take this as 2, I'm going to rewrite the numerator present in 2. Therefore 2 can be rewritten as y is equal to s positive t negative of s squared negative t squared divided by t negative s positive 1. Now we know that s squared negative t squared is s negative t times s positive t, right? We can use this formula. So if I were to use this formula, this is y is equal to s positive t negative of s negative t times s positive t divided by t negative s positive 1. So s positive t can be taken. So if I were to take s positive t out, I would get a 1 followed by quantity s negative t. Of course there is a parenthesis, and before the parenthesis you have a negative sign, so this has to be divided by t negative s positive 1. So this is what I've got. Now what I'm going to do is I'm going to rewrite this term present in the numerator. So this is equal to s positive t times 1 negative times s is going to give me negative s, negative times negative t will give me positive t divided by t negative s positive 1. Now t negative s positive 1, so they can be cancelled. So that would leave me with s positive t, and on the left we got y. So this is actually, what is it? This is nothing but secant squared x positive, in fact it's not secant squared x, it's just secant x. So it's secant x positive tan x. Now we will have to differentiate with respect to x. So this is going to give me dy over dx is equal to differential of secant x is going to be secant x tan x, and differential of tan x is going to give me secant squared x. Now we are expected to find the value of dy over dx at x is equal to pi over 4. Now let me use space here. Now tan pi over 4 is 1, and secant pi over 4, what is secant pi over 4? It's 45, right? So that is going to give me root 2. Why root 2? Because secant pi can pi over 4 can be rewritten as 1 over cos pi over 4. Cos pi over 4 is 1 over root 2, so when you flip it you get root 2. So that would mean, coming over here, this is going to give me root of 2, and root of 2 raised to the power of 2, which is equal to root of 2 positive 2. So that is the final solution, and probably we can box this entire thing. Okay, the box is flowing. So that completes this beautiful question. We'll move on to the next one. Students, we are given this question: f of x is equal to 1 positive x times 3 positive x squared raised to the power of 1 over 2 times 9 positive x cubed raised to the power of 1 over 3. So you have a product of 3 terms. So if you were to take this as u, v, w, you will have to find the differentiation of u, v, w. Now before I could proceed on with the differentiation of u, v, w, I would like to show you some rules in differentiation. See, the first law, which is called as the product rule or product law, if you are given 2 terms, say u and v, their differentiation would be u times v dash positive v times u dash. Now if you are given 3 quantities u, v, w, then their differentiation would be in this fashion: So we start off with u dash v w followed by u v dash w and then finally u v w dash. This is a very important formula you will have to know. Now if in case you are given u v w and some quantity t, so you got four terms u v w t. So in that case all you have to do is just write down these terms u v w t positive u v w t positive u v w t positive u v w t. And when it comes to differentiation, the differentiation operates like this. So we start off with u dash v w t and then u v dash w t and then u v w dash t and then u v w t dash. So all of these three formulae are important. So have it in mind and write them down and practice. Now in this case we are expected to find the differentiation of u v w. So what I'm going to do is I'm going to write them down as u v w positive u v w positive u v w. So it's going to be starting with u dash v w and u v dash w and then u v w dash, right? So that's a formula we will be using. So my u is 1 positive x. Differentiation of my u, that's u dash, is going to be 1. So this is what I've got. Now I have to differentiate v dash and I have to differentiate w dash. That's fine, but you have to make one important observation. V dash and w as well as vw dash, they have the term u being present with them. Now u as a quantity 1 positive x, we are expected to find f of negative 1. So the point what I'm trying to reach is, before you could differentiate, specifically whenever you are asked to find the functional value at a point, see if that particular value does really exist. In this case, let me show you this. I'm going to write that down. F dash of x is equal to differentiation of u is going to be 1 times the quantity v and w, that's going to be 3 positive x squared raised to the power of 1 over 2 times w is 9 positive x cubed raised to the power of 1 over 3. Positive, my u is 1 positive x, my v dash, I need to get my v dash. Let me just place v dash there followed by w and a positive sign and 1 positive x followed by v and w dash. Now we are expected to find f dash when x is equal to negative 1. If I were to substitute x is equal to negative 1, this vanishes. When I substitute x is equal to negative 1, this vanishes. So there is no point in investing your time in obtaining v dash and w dash. So make sure to have a idea of the overall picture whenever it comes to differentiation, because it involves time as well as effort when you want to differentiate something. So having mentioned that, I'm just going to substitute x is equal to negative 1 over here. So this is going to be 3, of course 1 is multiplied, 3 positive of negative 1 raised to the power of 2, that is raised to the power of 1 over 2, and 9 positive negative 1 raised to the power of 3, that is raised to the power of 1 over 3. This is going to give me 3 positive 1 raised to the power of 1 over 2 and 9 negative, because negative 1 raised to the power of 3 would give me negative sign, right, with the 1 being followed, and that has to be raised to the power of 1 over 3. Now 3 positive 1, that's 4, 4 is raised to the power of 1 over 2, 9 negative 1, that's 8, 8 is raised to the power of 1 over 3. Now 4 raised to the power of 1 over 2 would give me 2, 8 raised to the power of 1 over 3 would also give me 2. 2 times 2 is equal to 4. And what is that? This is f dash of negative 1. So this is a good place for us to draw the line. So we'll move on to the next question. Students, we are given this question: f of x is equal to x times modulus of x, and we are expected to show that f dash of x is equal to 2 times modulus of x. So I'm going to start off by writing the function, which is x times modulus of x. Now we need to start by defining the function. That's exactly what I'm going to do. Now if x is greater than or equal to 0, then modulus of x is going to be positive. That would mean it will open up with a positive sign. Of course there is a x there, so x into positive x would be giving me positive x squared. Now when x is less than 0, it would mean the modulus of x would open up with a negative sign, and hence I've got negative x. Along with that there is a x there. So this is going to give me a negative x squared. So this is how we define the function. So now that I've got the function, all I need to do is obtain f dash of x. So differentiation of x squared would give me 2 times x. However, x is greater than or equal to 0, and differentiation of negative x squared would give me negative 2 times x, with x being less than 0. Now what is this? This is nothing but 2 times modulus of x. This is exact definition for 2 times modulus of x. So you can simply say hence proved. So that is a good place for us to draw the red line. Students, we are given that y is equal to square root of 1 negative cos 2x divided by 1 positive cos 2x, with x lying between pi over 2 and pi. We expected to find the value of dy over dx. So foremost, what we would do is we would use this formula: 1 negative cos 2x divided by 2 is equal to sine squared x, and 1 positive cos 2x divided by 2 is equal to cos squared x. So if you were to use this formula, this is going to be 2 times sine squared x over 2 times cos squared x, and you got the square root sign there. So clearly 2 and 2 can be cancelled, and this is going to be square root of sine x over cos x is tan x. So sine squared x over cos squared x is going to be tan squared x. Now when you are taking the root of tan squared x, make sure to have a modulus sign, because square root operation produces a positive value, and that is the reason you will have to enclose it within the modulus sign. Now since this is a modulus function, you will have to know whether this modulus function opens with a positive sign or with a negative sign. So to judge that, let me draw the quadrant. Now this is 0, this is pi over 2, and this is pi. Now all silver teacups. So we are given a x which is lying between pi over 2 and pi. Now in this region only sign is positive, so that means tan will open up with the negative sign. So this is going to be equal to negative of tan x, and what is that? That's nothing but my y. Now we are expected to find dy over dx, so differentiating with respect to x we get, so this is dy over dx. Differentiation of tan x would give me secant squared x, so that has to be placed with a negative sign, and this is a good place for us to box the result. So we'll move on to the next question, students. Students, we are given this question: f of alpha is equal to cos of cot inverse of cos alpha divided by square root of negative cos 2 alpha, with alpha lying between pi over 4 and pi over 2. We are expected to differentiate this function. Now foremost, what I would like to do is I would like to change this cot inverse into cos inverse, so that can be coupled with this. So how are we going to get that? What I'm going to do is foremost I will just write cos here, and then I'm going to place cos inverse here. So let me just go and write the function in terms of cos. So first let us have this triangle. It's a right triangle, and this is alpha. Now let us just place cot alpha. Now cot alpha is given to be as cos alpha divided by square root of negative cos 2 alpha. So clearly from here alpha will be cot inverse of this, right? So cot is actually 1 over tan, right? Cot alpha is 1 over tan alpha, and we know that if this is opposite side, this is adjacent side, this is hypotenuse side, the tan alpha is going to be opposite side divided by adjacent side, and this would mean my cot alpha will be the reciprocal of this adjacent side by opposite side. So what we have to do is, first in terms, or I should say for adjacent side, I would have to place the first quantity. The first quantity here for adjacent side is cos alpha. So let me just write that down here. Now, as I mentioned to you, my intention is to write this expression cot inverse in terms of cos inverse. So clearly we know that cot alpha is adjacent over opposite side, and that would mean we would have cos alpha over root of negative cos 2 alpha. Now let us just represent this by means of a right triangle. So I've got this point A, and I've got this point B and C, and this is alpha. Now cot alpha is 1 over tan alpha. Now tan alpha is, if this is opposite side, this is adjacent side, and this is hypotenuse side, then tan alpha would be opposite side divided by adjacent side. So that would mean cot alpha will be adjacent side over opposite side. So as I mentioned to you, my cot alpha is this. So I need to place, in place of adjacent side, cos alpha here, and over here it is going to be square root of negative cos 2 alpha. Now clearly AC squared is AB squared positive BC squared. My AB squared is cos squared alpha. My BC squared is negative cos 2 alpha. So this is my AC squared. So my AC is what is required. So that's going to be square root of cos squared alpha positive. In fact, I could have taken this negative sign out. So let me do that. If I were to take that negative sign out, this would be negative of cos 2 alpha. Now cos 2 alpha is actually, we got a formula here, so let me write that down. Now cos 2 alpha is nothing but cos squared alpha negative sin squared alpha, which is also rewritten as 2 times cos squared alpha negative 1. So I can use this. So if I were to use this, this is going to be square root of cos squared alpha negative of 2 times cos squared alpha negative 1, which is going to be cos squared alpha negative 2 times cos squared alpha positive 1. Now negative 2 times cos squared alpha added with cos squared alpha would give me a negative cos squared alpha. I can rewrite that as square root of 1 negative cos squared alpha, which is root of sin squared alpha, which would give me modulus of sin alpha. Now we will have to be concerned with what sign this modulus of sin alpha opens up. Now we are given that alpha lies between pi over 4 and pi over 2. So if you were to draw that point, so this is 0 and this is pi over 2. So we are looking at a region in this fashion, pi over 4 to pi over 2, and alpha is actually present between these two regions which we have placed or which we have indicated here. Now in this case, all silver teacups, right? All ratios are possible here. So that would mean this is going to be opening up with a positive sign. So I did all these things to extract the value for AC. So what is AC? AC is actually sine alpha. That's it. Now we are interested in getting the value for cos. So from here, this would mean cos alpha, which is nothing but adjacent side divided by hypotenuse. My adjacent side is cos alpha and my hypotenuse side is sine alpha. So this is my cos alpha, but we are interested in knowing cos inverse. So if this is cos alpha, my cos inverse is going to be cos inverse of cos alpha over sine alpha. This is what we have got. So now what we're going to do is we are exactly going to take this representation. We're going to use this into the problem. So this is what is required, and from here I'm going to take that value and place it here. So what is that we have just got? That is nothing but cos alpha divided by sine alpha. Now clearly we can see that the cos alpha, or I should say the cos and cos inverse, they get cancelled, and that leaves me with cos alpha divided by sine alpha, which is nothing but cot alpha. And what is this? This is nothing but f of alpha. And what are we required? We are expected to find d by d alpha of f of alpha. So what is that equal to? That's nothing but d over d alpha of cot alpha. And what is differentiation of cot alpha? Negative cosecant squared alpha. So this is a good place for us to draw the red line, students, and we will move on to the next question. So I have explained you the entire solution in detail here. Students, we are given this question: square root of y negative x positive square root of y positive x is equal to 1. We are expected to find d squared y over dx squared at x is equal to 1. So solution, I'm going to write the problem down. Y negative x positive square root of y positive x is equal to 1. I'm going to be squaring both sides. So if I were to be squaring both sides, this is going to give me root of y negative x positive root of y positive x. This is raised to the power of 2. This is equal to 1 squared. If I were to square this, this is going to give me root of y negative x raised to the power of 2 positive root of y positive x raised to the power of 2 positive 2 times of root of y negative x multiplied with root of y positive x is equal to 1. This would give me y negative x, this would give me y positive x positive 2 times root of y negative x times root of y positive x is equal to 1. Now clearly negative x positive x can be cancelled, y and y can be added, and I can push it to the other side. So this is going to be 2 times root of y negative x times root of y positive x is equal to 1 negative 2y. Now I would be squaring both sides. So if I were to square this, the square root and the square, they get actually neutralized. So this is going to be 2 squared of y negative x times y positive x is equal to 1 negative 4 times y positive 4 times y squared. So what we can do is we can actually rewrite this as y squared negative x squared times 4 is equal to 1 negative 4y positive 4y squared, which is 4y squared negative 4 times x squared is equal to 1 negative 4 times y positive 4y squared. So 4y squared gets cancelled. Now what do you get? You get, on the left hand side you have negative 4 times x squared is equal to 1 negative 4 times y. Now what I wish to do, I wish to extract y. So I will push this to the other side. So 4y, I will bring this to this side. So 1 positive 4 times x squared, and rewrite this as y is equal to 1 positive 4x squared divided by 4. I'm going to rewrite this as 1 over 4 positive 4x squared over 4. 4 can be cancelled, so y is equal to 1 over 4 positive x squared. Now we are expected to find d squared y over dx squared at x is equal to 1. So differentiating with respect to x for the first time would give me dy over dx is equal to, this is 0, is equal to 2 times x, and then again differentiating with respect to x, d squared y over dx squared. When I differentiate 2x, I get 2. So the question wants us to find the value of d squared y over dx squared at x is equal to 1, but there is no need to apply this condition at all because this is totally deprived of the variable x. So that's a good place for us to box the solution, students. We will move on to the next question. Students, we are given f of x to be equal to x positive 1 times x positive 2 times x positive 3, etc. up unto x positive n. We expected to find f dash of 0. Now foremost, what I would do is I would like to rewrite f of x as y, and then the other terms are just as they are. So you got a product of this many terms. Now whenever you are given quantities in product form, you will have to use log. So taking ln both sides, we get, because for the simple fact ln actually converts anything which is in product form into the sum form, and anything which is in sum form is easy to differentiate and more so to solve. So this is going to be ln y is equal to ln of this entire quantity x positive 1 times x positive 2 times x positive 3 up unto x positive n. Now we know that, what do we know? Ln of AB is equal to ln A plus ln B. So if you were to use this particular formula, I would be able to rewrite this as ln of x positive 1 positive ln of x positive 2 positive ln of x positive 3 plus etc. ln of x positive n. On the left you got ln y. Now what I'm going to do, I'm going to be differentiating with respect to x, both sides. We get, so what do we get when you differentiate ln y? You get 1 over y times dy over dx. And differentiation of ln of x positive 1 is 1 over x positive 1 times differentiation of x, that's going to be 1. So this is going to be 1 over x positive 2 times differentiation of x positive 1 over x positive 3 plus etc. 1 over x positive n. This is what I've got. Now I can move the y to the right, so I would get dy over dx is equal to y times 1 over x positive 1 positive 1 over x positive 2 positive 1 over x positive 3 etc. positive 1 over x positive n. This is what we have got. Now if I were to take x is equal to 0, okay, since we need f dash of 0, So this means dy over dx at x is equal to 0 has to be found. Now before I could move on, I want to show you what happens when y takes the value x is equal to 0. This is 0, this is 0, this is 0, this is 0, and what we get is 1 multiplied with 2 multiplied with 3 up unto n. What is this? This is nothing but n factorial. So having got that, this is going to be n factorial times 1 x is equal to 0, 1 over 2 plus 1 over 3 plus etc. x is equal to 0, 1 over n. And that is exactly the required solution, and that's a good place for us to draw the red box. So we'll move on to the next question. Students, we are given this question, f of x is equal to, this is called the product function. So we're given a product function x negative n raised to the power of n times 101 negative n. And we are expected to find f of 101 over f dash of 101. So this is required. Now foremost, let me write the product function in detail. So this is f of x is equal to, n takes the value 1 to 100. So it's going to be x negative 1 for n is equal to 1, and 1 times of 101 minus 1. So what do we get? That's 100. Times, it's a product function, x negative n is equal to 2, that has to be raised to the power of 2 times of, now 101 minus n is equal to 2, so that is going to be 99, and n is equal to 3, so 3 raised to the power of 98, and it goes on up unto x negative n is equal to 100. So you're going to have 100 here, and that has to be multiplied with 1. So this is the entire outlay, or I should say the entire output for the product function. So instead of writing like this, you can use this symbol and write the product function. So now what I'm going to do is I would be taking ln both sides. So if I were to take ln both sides, I would get ln of f of x is equal to ln of this entire quantity, x negative 1 raised to the power of 1 times 100 times x negative 2 raised to the power of 2 times 99, etc. up unto x negative 100 raised to the power of 100 times 1. Now we know that ln a times b is ln a plus ln b. Now using this, what I can do is I can rewrite this as ln of x negative 1 raised to the power of 1 times 100 plus ln of x negative 2 raised to the power of 2 times 99 plus ln of x negative 3 raised to the power of 3 times 98, etc. ln of x negative 100 raised to the power of 100 times 1. Now we have another formula, ln of a raised to the power of b is b times ln a. So by that I can rewrite this as 1 times 100 times ln of x negative 1 positive 2 times 99 ln of x negative 2 positive 3 times 98 ln of x negative 3, etc. 100 times 1 ln of x negative 100 is equal to, this is ln of f of x. So this is what I got. So now I need to differentiate. So differentiating with respect to x, we get, so what do we get? This is 1 over f of x times differentiation of f of x, that's f dash of x. This is equal to 1 multiplied by 100, 1 over x negative 1, that's a differentiation of ln of x negative 1, times differential of x is 1. So this is going to be 2 times 99 divided by x negative 2. There's no need to place this dot 1 there because it's going to be 1 anyway. So followed by 3 times of 98 over x negative 3, and then it goes up to 100 times 1 over x negative 100. So this is what we have got. So now the question comes, we will have to make the substitution at x is equal to, this is required, 101, right? So let us substitute that value. So at x is equal to 101, what happens? This is going to be f dash of 101 divided by f of 101. This is going to be 1 multiplied with 100, so let's retain that, divided by 101 minus 1, that's going to be 100. This is going to be 2 times 99 over 101 minus 2, that's going to be 99, plus 3 times 98, 101 minus 3, that's going to be 98, and it is going to go on up until 100 times 1 divided by 1. So what happens here, I can cancel this with this, this with this, this with this, this with this, and what do I get? I get 1 positive, 2 positive, 3 positive, etc. 100. What is this? This is of the form n into n positive 1 divided by 2, which is 100 times 101 divided by 2, which is 2 divides here 50 times, so 50 times 101, which is 5050. 5050. This is what I get. But what is this exactly? This is f dash of 101 divided by f of 101. This is 5050, but we need f of 101 over f dash of 101. This is f dash, so just reverse this. So this implies f of 101 divided by f dash of 101 is equal to 1 over 5050. So that is a good place for us to draw the red line. So that completes this beautiful question, students. So we got a question, given that f is a function from s to s, where s is defined with the open interval 0, infinity, and it says that the function is twice differentiable, and that f of x positive 1 is equal to x times f of x. We are also given another function stretching from s to r, and it is defined as g of x is equal to ln of fx. We are expected to find the modulus of g double dash of 5 negative g double dash of 1. So how are we going to do this? And this is a question involving differentiation. So foremost, what I'm going to do is I will start off like this. So we are given, so what are we given? We are given f of x positive 1 is equal to x times f of x. So this is what is given. Now from here I am going to be using some, what should I say, some ways of representing quantities. So I'm going to actually have f of x positive 1 over f of x is equal to x. So this is the way I'm going to write. So now I'm going to be taking ln both sides. So if I were to take this as 2, I'm going to take this as 1. Now we are also given that g of x is equal to ln of f of x. So let me take this as 3. Now from here, taking ln both sides, I am having actually ln of f of x positive 1 over f of x is equal to ln of x. So this is what I've got. Now since ln of a over b is ln a negative ln b, I can rewrite this as ln of f of x positive 1 minus ln of f of x is equal to ln x. So this is what I can write as. But from 3 we got, so what exactly we have from 3? From 3 we got g of x is equal to ln of f of x. So this is going to be g of x and this is ln x. Now g of x is this, hence g of x positive 1 is equal to ln of f of x positive 1, right? You agree with me? I'm just replacing x by x positive 1. So all these things for your understanding. So this is going to be, instead of ln of f of x positive 1, I'm going to write it as g of x positive 1 followed by a negative sign. So this is the equation that we will be using. Now we are asked to find this. Okay, this is actually the requirement. So let me use a red line there. So with that, I need to find double differentiation. So differentiating with respect to x, we get, so what do we get here? We get g dash of x positive 1 negative g dash of x is equal to ln of x, differentiation is 1 over x. Now again we need to differentiate this. Differentiating with respect to x, we get, so what do we get when you differentiate this? G double dash of x positive 1 negative g double dash of x. Differentiation of 1 over x is negative 1 over x squared. So we got a good equation which we would be using. Now as I mentioned to you, we need this quantity g double dash of 5 negative g double dash of 1. So we have to start off with, let x be equal to 1, 2, 3, 4. I think we need to stop up unto 4. So when x is equal to 1, this is going to be g double dash of 1 positive 1, 2 negative g double dash of 1 is equal to negative, x is equal to 1, this is going to be 1, and x is equal to 2, g double dash of 3 negative g double dash of 2 is equal to negative, x is equal to 2, that's going to be 1 over 4, x is equal to 3, this is g double dash of 4 negative g double dash of 3 is equal to, x is equal to 3, so it's going to be negative 1 over 9, and x is equal to 4, g double dash of 5 negative g double dash of 4, x is equal to 4, negative 1 over 16. So this is what we have got. Now what we have to do is, we will have to add. So if we are adding, then what happens? This gets cancelled with this gets cancelled with this gets cancelled with this, and so after cancelling all of this, we are left with this g double dash of 1 and g double dash of 5. So what I'm going to do is, I'm going to write them here. G double dash of 5 negative g double dash of 1 is equal to, on the right hand side I've got a negative 1 that has to be added with all of these terms. So it's going to be negative 1, negative 1 over 4, negative 1 over 9, negative 1 over 16. So I'm going to take a negative sign out. If I were to take a negative sign out, I would get 1, positive 1 over 4, positive 1 over 9, positive 1 over 16. Now on the left hand side, we are expected to find the modulus of this. So if I were to take the modulus, so it's going to be mod of g double dash of 5 negative g double dash of 1. So modulus of this means modulus of this, which would mean this negative sign would be dropped, and all we need to do is to take the sum of 1, positive 1 over 4, positive 1 over 9, positive 1 over 16 over here. So to perform the calculation, so we got modulus of g double dash of 5 negative g double dash of 1. This is what is required, which is equal to, since I've taken the modulus, I am left with 1, positive 1 over 4, positive 1 over 9, positive 1 over 16. Now clearly the LCM is going to be 144, and this would give me 144, and this 4 divides 144 36 times, and this would give me 16 times, and this would give me 9. So if I were to add up all of these, this is going to give me 205 divided by 144, and this is a good place for me to draw the red line. So therefore, just to sum up, the value that we have got over here is 205 divided by 144. So this is the final solution for this question. Thank you, students. Students, we are given this question. F of x is equal to sine of cos inverse of 1 negative 2 raised to the power of 2x divided by 1 positive 2 raised to the power of 2x. And its first derivative with respect to x is given to be as negative b over a times ln 2. When x is equal to 1, so this is the what I would say, this is given when x is equal to 1. And a and b are integers, and we are expected to find the minimum value of modulus of a squared negative b squared. So first, let us place the function. F of x is given to be as sine of cos inverse of 1 negative, now 2 raised to the power of 2x. I'm going to write this as 2 raised to the power of x raised to the power of 2 divided by 1 positive 2 raised to the power of x raised to the power of 2. Now why am I able to do this? Because a raised to the power of m times n can be rewritten as a raised to the power of n times m, and further you can also rewrite this as a raised to the power of n the whole raised to the power of m. So all directions are possible, and also a raised to the power of m raised to the power of n. So all of these things are possible from the law of indices. That's exactly what I'm doing. Now there is a formula. Now what is the formula? The formula is cos 2 theta is equal to, let me write it like this, 1 minus tan squared theta divided by 1 plus tan squared theta. So this is a important formula I'm going to use. This is 1. So based on this formula, I'm going to make some arrangements here. So what I'm going to do is, I'm going to say let 2 raised to the power of x be equal to tan theta. Let me take this as, say, 2. So therefore 2 can be rewritten as f of x is equal to sine of cos inverse of 1 negative 2 raised to the power of x is tan theta. So that's going to be 1 negative tan squared theta divided by 1 positive tan squared theta. So this would mean cos 2 theta. So this is equal to sine of cos inverse of cos 2 theta. So clearly cos inverse and cos can be cancelled, and that would give me sine 2 theta. Now this is f of x, okay, now which is nothing but y. This is y. So we have y is equal to sine 2 theta. Now let's go to the problem. The problem says, and its first derivative with respect to x is this. So we have to get the dy over dx. Now dy over dx on the left side, but on the right side we have theta here. So we have to be a little bit cautious. So what we have to do is, we have to get dy over dx, and in this case when we are differentiating, the differentiation is achieved in this fashion. So of course we have to differentiate with reference to d over dx, right? But I'm going to write it like this: d over d theta times sine 2 theta times d theta over dx. So actually what am I doing here? I'm just adding a d theta and removing a d theta, for the reason that I have sine 2 theta. Okay, so this differentiation is possible. It's simple. Now, what are we going to do for d theta over dx? Where am I going to get the value? Now, I've just taken this as 2. I'm going to take this as 3. Now, you can see here, 2 raised to the power of x is equal to tan theta. So, let me use this part of the space. Okay, from 3, differentiating with respect to x. Okay, so differentiation of 2 raised to the power of x, this is a straightforward formula, 2 raised to the power of x times ln 2, and differentiation of tan theta is secant square theta times d theta over dx. So I've got d theta over dx. So this would, from here I can rewrite d theta over dx to be as 2 raised to the power of x times ln 2 divided by secant square theta. Okay, that's fair enough. So I've got dx theta over dx, and I've got a sine 2 theta. I need to differentiate this. So this is equal to, if you were to differentiate this, differential of sine gives me cos 2 theta, differential of 2 theta will give me 2. So this is what I've got. This has to be multiplied with d theta over dx, which is nothing but 2 raised to the power of x times ln 2 divided by secant square theta. That's fine. So we have got dy over dx. That's beautiful. Now 1 over secant square theta. Now what is 1 over secant square theta? 1 over secant square theta is nothing but cos square theta. So this is equal to, I can rewrite this as 2 times cos 2 theta times cos square theta times 2 raised to the power of x times ln 2. This is equal to dy over dx. Okay, let's go back to the problem. It says find its first derivative with respect to x is given to be as negative b over a ln 2 when x is equal to 1. So at x is equal to 1, what happens? At x is equal to 1, this is equal to, x is equal to 1, 2 times 2 is 4, and this is going to be cos 2 theta times cos square theta times ln 2. So you got a cos 2 theta and cos squared theta. Now we need to get these values. So how I'm going to get these values, I'm going to show you that in a minute. Now foremost, I want to get rid of this cos 2 theta. Now what is cos 2 theta? Now cos 2 theta is equal to cos square theta minus sin square theta. Now sin square theta is nothing but 1 minus cos square theta. So this is nothing but 2 times cos square theta minus 1. So this is what I've got. So I'm going to substitute this there. So 4 times of, in place of cos 2 theta, let us substitute 2 times cos square theta minus 1 times cos square theta times ln 2. This is going to be 2 times 4, that's going to be 8 times, I've got cos to the power of 4 theta. Well, I can just retain it as it is, so I don't want to do any further simplification. I will just locate the values of cos and then I will substitute. Now how am I going to obtain the value of cos? Now from 3 we got 2 raised to the power of x is equal to tan theta. So let me just use that. So I'm going to use this part of the page. Okay, from 3, so what do I got? 2 raised to the power of, and x is equal to 1, right? So x is equal to 1 means this is going to be, x is equal to 1, this is going to give me tan theta. Now if I were to take the Pythagorean triangle, tan theta is opposite by adjacent, so this is going to be 2 over 1, and this is going to be root of 5, right? So from here my cos theta is going to be 1 over root 5, right? Because sin theta is opposite over hypotenuse, tan theta is adjacent over hypotenuse. So I've got a cos theta. So cos theta is this, therefore cos square theta, what is cos square theta, is equal to 1 over 5. So probably I can substitute that. So this is equal to 4 times of 2 times of 1 over 5 1 over 5 negative 1, that's fine for this, times 1 over 5 times ln 2. So this is equal to 4 times of 2 over 5 negative 1 times 1 over 5 times ln 2. This is equal to 4 times 2 negative 5, that's negative 3 over 5 times 1 over 5 times ln 2. This is going to give me negative 12 over 25 times ln 2. What is this? This is dy over dx at x is equal to 1, which is given to be as negative b over a ln 2. You see that? The first derivative with reference to x is negative b over a. So this is negative b over a ln 2, and this is negative 12 over 25 times ln 2. So this implies my b is 12 and my a is 25. We are expected to find the value of a modulus of a squared negative b squared. So therefore modulus of a squared negative b squared is equal to modulus of 25 squared negative 12 squared, which is 625 negative 144. So 625 144, I get a 1, and this is going to be 12, and I get 8 and 5, 481, right? So the solution is going to be 481, and that is a good place for us to draw the red line. Thank you, students. We move on to the next question. Students, we are given this question. F of x is differentiable at x is equal to a, and f dash of a is equal to 2, and f of a is equal to 4. We are expected to find the value of the limit. So I will start off by applying the limits. If I were to apply the limits, this is going to be a times f of a. So it's going to be a times f of a followed by a times f of a divided by x. X is going to be a negative a. So this is clearly 0 by 0 form. Now once you get this form, we can apply the L'Hopital rule. So that's exactly what I'm going to do. Applying the L'Hopital rule. So what is the L'Hopital rule? It's a differentiating the numerator, dividing it by the differentiation of the denominator. So if I were to differentiate this, u into v. So let me write that formula. Differentiation of u into v will give me u times v dash plus b times u dash. This is actually the formula which we have to use, right? But f of a is constant, so that will give me 0, followed by f of a times the differential of x. So it's going to be 1 times f of a. That's it. Negative a times differentiation of f of x is going to give me f dash of x, divided by differentiation of x is going to be 1. Of course, a is a constant, its differential is going to be 0. So this is going to be equal to, now we got 1 times f of a, negative a times f dash of x. Now what we have to do is we have to substitute the value. F of a is 4, so there's going to be 4 negative a. My a is retained as it is, f dash of x at x is equal to a, because this is actually, in this case we are applying the limits, so x is tending to a. That's the reason I need to find f dash of a. So f dash of a is going to be equal to 2. So if I were to rewrite this, this is going to give me 4 negative 2 times a. So maybe I can place a parenthesis. So from here onwards, we are actually looking to apply the limits and extract the value, and that is the reason we are able to utilize these values. F dash of a, of course f of a is there, but in this case of f dash of a, we just have f dash of x, and f dash of x is actually f dash of a for the fact that x is tending to a. So the final answer is going to be this 4 negative 2a, and that's a good place for us to draw the red line and move on to the next question.